Physics Part 401. The light dependent resistors, LDR. A light dependent resistor, LDR, consists of two metal grids that intersect each other. The space between the grids is filled with semiconductor material, for example, cadmium sulfide doped with copper. When light is incident on the semiconductor material, the number of electrons in the semiconductor that are free to conduct increases. The higher the intensity of light on the LDR, the greater the number of electrons that can move freely. Hence, as the light intensity increases, the resistance of the LDR decreases. The figure shows variation with light intensity of the resistance of a typical LDR. Both light intensity measured in lux and resistance measured in ohms are plotted on logarithmic scales in the figure. The graph is a straight line, but this does not mean that resistance is inversely proportional to intensity. Data relating to the light intensity and resistance for a typical LDR are shown in the table. While the light level is supposedly moonlight, the illumination lux is 0.1 and the LDR resistance is 1 into 10 power raised to 6. The light level is normal room lighting. The illumination level is 450 lux and the LDR resistance is in omega 900 omega. The light level of sunlight is illumination 28,000 lux and the LDR resistance is 100 omega. The lux is a unit that is used to measure the light power incident per unit area of a surface. The thermistor. The resistance of most metals increases to a certain extent with rise in temperature. Negative temperature coefficient devices, often referred to as thermistor, are made from semiconductor material, usually the oxides of metals. The resistance of thermistor decreases significantly with rise in temperature. Thermistors are manufactured in various shapes and sizes, including rods, discs, and beads. The figure shows an example of a disc and bead thermistor. Data relating to the temperature and resistance of a typical bead thermistor are shown in the table. The variation with the temperature of a typical thermistor is shown in the figure. This variation is not linear and is in fact approximately exponential over a limited range of temperature. If the temperature is 1 degree Celsius, the thermistor resistance is 3700 omega. If the temperature is 10 degrees Celsius, the thermistor resistance is 2500 omega. If the temperature is 20 degrees Celsius, the thermistor resistance is 1800 omega. If the temperature is 30 degrees Celsius, the thermistor resistance is 1300 omega. If the temperature is 40 degrees Celsius, the thermistor resistance is 900 omega. If the temperature is 50 degrees Celsius, the thermistor resistance is 660 omega. It shows a curve falling down curve resistance versus temperature of a thermistor. The table has been put into a figure and we can see a loop here, a descending loop with the rising temperature. Next, we'll talk about piezoelectric transducer in our next video.